Hello everyone, this is Dr. C. Hope you're doing well today. So this will be really quick. I just want to introduce you to the concept of a rate law. Now we'll spend some more time in class talking about exactly the definition of reaction rate and how we define it in terms of a reactant or a product, something like that. But what we're going to try to get to in the first part of this chapter is something called the rate law. So let me show you what that tells us. It's going to be very important in this chapter. So we're going to focus on initial rate. And so we're going to look at how the rate at the very start of the reaction depends on the starting concentrations. So we're going to start only with reactants. And we're going to measure, well, we're not actually going to measure. If you're in the laboratory, you could measure the rate right at the start of the reaction. We will give you the initial rate of the reactions and the types of problems you will do. Okay? So an initial rate will be given. How do the starting concentrations of the reactants impact the rate of the reaction? And again, rate is just the speed of the reaction. Now, why would we choose initial rate? Well, we're going to find as we go into more detail, typically as reactant concentrations decrease, the reaction will slow down. Typically. All right, and oh, I hate when I get over there and do that. Sorry about that. So that's supposed to say typically. So in general, as reactant concentrations decrease, there are fewer reactant molecules to collide. And if there's fewer molecules to collide, the reaction rate's going to be slower. The other reason why we measure initial rate is that after products start to build up, so we start running the reaction, reactants go to products, some of the products are going to go in the reverse direction, and products are going to go back to reactants. So that's going to impact our rate. All right? So this kind of simplifies everything. So the rate right when the reaction starts. Now you might see in some of the problems in the pre-lecture quiz, you might see, I think maybe one of them has this, it'll say at t equal to 0. That means time 0. That's another way to say initial, right at the start of the reaction. What is the rate? Okay? Now, what is the rate law? So this is just some generic reaction. Okay? The key is that we have two reactants, A and B. Since we're looking just at initial rate, we don't have to worry about the products. Right? Products haven't built up yet. That makes our life a little bit easier. So this is the general form of the rate law. Okay? The rate is equal to something called the rate constant. So K is the rate constant. Oh, sorry. Rate, there should be a space there. Rate constant. All right, so the rate is equal to a rate constant times the concentration of each reactant. So again, we just focus on the reactants. So reactant A times reactant B. Now you'll notice these X and Y's. Okay, so they're going to be raised to some power. Raised to some power. And we're not going to do this in this pre-lecture, but that is going to be one of the harder calculations for this chapter, is actually determining X and Y, what we call the order or orders of each reactant. Okay? Now for this pre-lecture quiz, you'll just be given the rate law for a reaction. Okay? And you'll have to be able to determine the order. Okay? So for example, if the overall reaction order, if the problem asks, it's just what X and Y are. So you might have something that's just rate is equal to K A times B. Okay? Each of these exponents is 1. So we would say the reaction is first order with respect to A, it's first order with respect to B, it's second order overall. Okay, so the overall order is just the sum of the orders with respect to each reactant. All right. There will be other questions on the pre-lecture quiz where you might be given given the rate law, and let me actually write this down. You might be given a rate law just like the one, say, we have up here. And you might be given the rate constant, the initial concentration of A and B, and you might solve for the rate. Okay? Another one might be turned around, that you'll have the initial rate, you'll have the two concentrations, and you'll solve for the rate constant. Okay? So this is just trying to introduce us to what a rate law looks like. So all I wanted to do in this pre-lecture is introduce you to the form of the rate law. It will always have this form. Let me scroll back up again. Rate will equal to a rate constant K, concentration of each reactant raised to some power. Now we're going to have to figure out how to solve for X and Y. We're going to save that for class. Now realize one thing I should point out here. The X and Y values do not equal coefficients. Okay, so our coefficients in the balanced equation, you know, on a rare occasion it might work out to be like that, but we don't just get those from the coefficients. We actually have to look at data and solve for those. And that's a pretty difficult calculation. We'll save that for class. But know the general form, know what it means to say the overall order of a reaction and the order with respect to each reactant, and then know how to plug into a given rate law to either solve for rate or solve for the rate constant. And that's all I wanted to do with this pre-lecture. That's it. I think I'm done. Okay? So practice, you're going to do 2 calculations in the pre-lecture quiz. One solving for rate, one solving for rate constant. I think there's another one that just asks for the overall order of a reaction, and that's all there is to it. So very, very quick introduction to rate law. We'll do more of this in class, and we'll actually learn how to solve for the rate law. And that's the next step. Okay, I will see you soon.